Alright, welcome to Chapter 11, Section 4, Translations and Reflections in the Coordinate Plane. A transformation is an operation that's going to map an original geometric figure, sometimes called the preimage, onto a new figure called the image. For certain types of transformations, the original figure and its image are congruent. Congruent means it's going to have the same shape and the same size. We've been saying that congruent means equal, so it makes sense that the beginning figure, the original figure, the preimage, is going to be the same shape, or it's going to be equal to the new figure, the image, after it's transformed. The first type is called a translation, also called a slide. So we're moving things up and down and left and right. The translated image and the original figure are congruent. They're the same shape and the same size. The orientation is the same as the original figure, meaning that it's not a mirror image. It's facing the same direction. So this first picture is taken directly from your book. You see that the green bee and the blue bee are the same shape and the same size. All you do with the green bee is move it down and to the left to get the blue bee. When translating a figure, every point of the original figure is moved the same distance and the same direction. So what are you going to do to translate? Well, first of all, this picture is taken directly from your book, but there is a typo. So please change this to D prime and this to C prime. When you see the primes next to the letters, that means that that's the new figure. So in this case, the blue is the original and the green is the image. So if we are moving every single point the same distance in the same direction, we really only have to look at one point and how it's moved to determine how the whole figure is moved. So let's look at just A and A prime from this one. The coordinates of A are at 1, 2, 3, 4, 5, negative 5, comma, 1, 2, 3, 4, 5. A prime on the new figure is at 0, comma, 1, 2, 3, 4, 5. So let's figure out how we move from one to the other. Well, from negative 5 to 0, we added 5. From 5 to 5, there was no change. So I could write it as a rule like this. I take any coordinate, x, comma, y, and I'm going to add 5 to the x, and I'm not going to change the y. If I wrote this out in words, I could say the blue figure is moved 5 to the right. Let's look at the next one. How about J and J prime? The coordinates of J are 1, comma, 0. Not 1, comma, 0, negative 1, comma, 0, and J prime is at negative 1, comma, 1, 2, 3, 4. So let's see how this one moves. Negative 1 to negative 1, there's no change. 0 to 4, I add 4. So let's write it as a rule. I take any point, x, y. My x stays the same, but the y, I'm adding 4. So if I wanted to write this out, I could say we move the figure 4 up. Let's try one more. R and R prime. R is at 1, comma, 1, 2, 3, 4, 5. R prime is at 1, 2, negative 2, comma, 0. So, to move from 1 to negative 2, what did I do? And to move from 5 to 0, what did I do? Think about it for a second. Well, from 1 to negative 2, I'm subtracting 3. From 5 to 0, I'm subtracting 5. So I'm doing two things at once. I'm taking my x comma y, and my x I'm subtracting 3, and the y I'm subtracting 5. If I wrote this in words, I'm going 3 left and 5 down. So you really only need to look at one point to figure out what you're actually doing. Now this is all, again, on page 522 if you want to look at it. So I could rewrite this in a formula. I could say, if my point is some xy, it's going to become the new point by adding or subtracting to each the x and the y. So let's look at a problem. Triangle ABC is translated so that B prime is the vertex of the image. And you'll see the triangle ABC on that graph, and you also see B prime. They want to find the coordinates of A prime and C prime. So let's look at how B changed. Well, B was at 0, 1, 2, 3, 4. And it became B prime. B prime is at 1, 2, 3, 4, negative 4, 1. So what happened? Well, from 0 to negative 4, I subtracted 4. From 4 to 1, I subtracted 3. So I could write my rule as whatever my xy is, it's going to become x minus 4, y minus 3. Okay, if I wanted to write it in words, I could say left 4, down 3. So let's write out our new coordinates. A was at 1, 1. B I already had, so I don't have to do B. And C, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I'm going to perform my equation on each of these. I'm going to take 1, 1, and I'm going to subtract 4 from the x and subtract 3 from the y. 1 minus 4 gives me negative 3, and 1 minus 3 gives me negative 2. 4 minus 4 gives me 0, and 6 minus 3 gives me 3. So I have my two new coordinates, my A prime and my C prime. Suppose that triangle ABC is translated 8 units down and 6 units, or 8 units right, and 6 units down. Find the coordinates of this new image. So let's use the words and write it as an equation. Okay, units right is going to give me an x direction, and right is positive, so that means I'm adding to my x. I don't know why I wrote 5, 8. 6 units down is a y direction, so my y is going to subtract 6. So let's start with our original coordinates. We're going from the same problem, so A is 1, 1, B is 0, 4, and C is 4, 6. And I'm going to perform my transformation to find my new coordinates, my A prime, B prime, and C prime. 8 plus 1 is 9. 1 minus 6 is negative 5. 0 plus 8 is 8. 4 minus 6 is negative 2. C prime, 4 plus 8 is 12. 6 minus 6 is 0. So we have our new coordinates at 9, negative 5, 8, negative 2, and 12, 0. The last transformation for today is a reflection. A reflection is also called a flip. figures are mirror images of each other. The reflected image and the original figure are congruent, meaning they're the same shape and the same size, but the orientation is different because they are mirror images of each other. You flip the figure over the line that we call the line of reflection. The corresponding parts are the same distance from that line of reflection. So in this picture, copied directly from your book, this is our line of reflection. If I look at this point on the B and this point on the B, this distance here is the same as this distance here. I could do that with every single point. If I picked this one and this one, from here to here is the same as from here to here. So what do you do for a reflection? Well, we have two of these, reflection over x-axis and reflection over y-axis. This is copied from your book in page 523. In the x-axis, you'll notice you're going from positive y to negative y. Reflection in the y-axis, you're going from the positive x to the negative x. So your coordinates are going to flip. Reflection over the x-axis, we can write our formula like this again. The x-coordinates stay the same, but the y switches signs. When you reflect over the y-axis, the y-coordinate stays the same, but the x is going to change signs. So let's see. The vertices of triangle ABC are given here. Graph the triangle and its reflection over the x-axis. So if we're reflecting over the x-axis, you can go back up here, look at your formula. That means the y is going to switch signs. So that means my x, y, my x for each of these stays the same, but the y is going to become the opposite. So let's graph the original here in green first. I'm going to go to 4, -2, 0, 2, and 5, 2. Okay, if we want to write it out, I can write out each of my coordinates before I go to graph it. So again, the x's are going to stay the same. So the x is still going to be 4 for A, 0 for B, and 5 for C. But the y is going to change signs. So it was negative, now it's positive. It was positive, it's now negative. It was positive, it's now negative. I'm going to graph this one in pink. So I'm at 4, 2, 0, -2, and 5, -2. So now if you look at these two, they're just mirror images of each other. Let's try another one. The vertices of WXYZ are given. Graph the rectangle and its image after a reflection in the y-axis. So let's write our formula. Reflection in the y-axis, if you want to scroll back up and look, you can. Reflection in the y-axis, we had the x change signs, and the y stays the same. So let's graph the first one. -3, -3, -3, 4, oops, not prime, 2, 4, and 2, -3. so I have my rectangle. And again, if it helps you out, take a second and you can write out your coordinates. So this time my y's are all the same. But my x is going to change signs. So in W, my original x was negative, it's going to become positive. In x, my original x was negative, it's going to become positive. In y and z, they were both positive, so they're going to become negative. So notice, this does not necessarily mean that it becomes negative, it just means it switches signs. So I'm going to go ahead and graph this one in green now. I'm going to be at 3, -3. So you can kind of see it flopped from one side to the other. X is going to be at 3, 4. So again, it flopped from here to here. -2, 4. And -2. Oops, my y prime's in the wrong spot, that's why. Let's fix this. -2, 4 is up here. There we go. And -2, -3. And there we go. This one is reflected over the y-axis. So that's going to conclude section 4. I suggest that you use graph paper for this. So there's a couple different options that you can use for that. You can use GeoGebra to turn it in. You can do it by hand and take a photo of it. You just let me know what works best for you, and you can do your homework that way, but I do suggest